wait until the actual test to try it out for the first time. All right. So what is being done to the variable here? Divided by, opposite of that would be multiplying by 9. So do that on each side. On the left side, what happens to the 9s? They cancel out. So we have just A. On the right side, what's negative 4 times 9? Positive or negative? Negative 36. Remember, count the number of negative signs. Oh, that's okay. So one negative sign, odd number, our answer is negative. Any questions? All right. So those pretty easy, right? Only one thing that needs to be undone, and that's clear. Now fractions, I know still trip up some students. So let's review those, how to get rid of fractions or undo fractions. So still look at what's being done to the x. What is being done to the x? It's being multiplied by the 2/3. It's being, when it's squished up right against it, there's no symbol. That implies multiplication. So in order to undo multiplication, what do? We divide. Now, when it's a fraction, it looks a little messy, right? We have a fraction divided by a fraction. Now, you ever heard of that trick when you're dividing fractions, the copy dot flip or keep change flip?
Oh, change flip.
All right, so that means when you're dividing fractions, you keep the first fraction or copy the first fraction, change the division to multiplication, and then you flip the other fraction. So this is equivalent to dividing by a fraction. So instead of going through that whole process every time, you can just think of getting rid of fractions. You are actually multiplying by the reciprocal. That's that word. So fill that in right here. To get rid of a fraction, multiply by the reciprocal. All right, because that's what we're doing here. I'm going to erase what I wrote in red. And instead of, writing what I had originally, I'm going to multiply by the reciprocal, which is the same thing. Good on that? Does that make sense? Mm-hmm. So on the left side, what happens to the fractions? They cancel out. On the left side, we just have x. And on the right side, you can either cross simplify or you can multiply straight across, then divide, whatever your preference. What's 10 times 3? And then divided by 2. Not 20.
15.
It is 15. Someone said that earlier today too. That mental math.
Oh.
All right, it's half of 30 is 15. All right, but does that make sense? All right, so now let's do number 7 together, then I'll have you try one on your own. So number 7, what's the reciprocal of negative 6 over 5? Good. And the placement of the negative doesn't matter. As long as it's in either the numerator or denominator, that's fine. But yes, so this is the reciprocal. Whatever you do to one side, so I'm going to multiply the other side by negative 5 over 6. What happens to the fractions on the left? They cancel out. That's the whole reason we did that. So that they would cancel out and we get the variable by itself. And then on the right side, you got to simplify that. Either cross simplify or multiply straight across. I'll show you cross simplifying though for a second, if you're not familiar. So when you're cross simplifying, look at like the diagonal numbers, like go like this way. Over here, so this is really 12 over 1. Is there a number that goes into 1 and -5 other than 1? So we can simplify that one, right? That one's already simplified. When you look this way at the 12 and 6, is there a number that goes into both of those? What's the biggest one that you can think of? 6. So I can cross simplify. 6 goes into 12 how many times? Twice. 6 goes into 6 once. And now it's just 2 times -5, which is -10. All right, so that's a little trick. If you don't like just multiplying straight across and dividing, either way, whatever way you chose to do it, if you did it right, you should have gotten -10. All right, cross simplifying is usually better when you don't have a calculator. But any questions? Okay, I'm going to give you one to try, and that'll be number 8. So you guys try number 8. All right, I skipped the other one, but that's all right. All right, so you guys try number 8. So number 8, I had you guys try. So in order to get rid of the fraction, what can I do? Keep, change, flip, which is the shortcut to that would be multiplying by the reciprocal. So what's the reciprocal of -1/2?
2.
And don't forget there needs to be a negative in there somewhere, but yes.
I'm sorry, it has to be 7.
And then what happens to the fraction on the left side?
Yes.
They cancel out. We get just m. On the right side, multiply this out. What's -9 times -2? +18. Should be positive.
Yeah, nice.
All right, good. All right, because this was a -1/2, so the reciprocal should be like -2. Questions about fractions? All right, so all of those were one-step equations. Those are a little easier because you only have one thing that needs to be undone, and there's no like special order you need to go in because there's only one thing. For two-step equations, there's multiple things that need to be undone in order to isolate the variable. So you have to pay attention to which one needs to be done first, because order does matter. If you try to do it out of order, you will get a different answer. So there's a couple things that I tell my students to help them figure out what to get rid of first. The first thing I tell them is to imagine that we are doing order of operations just in reverse. All right, so that's an arrow.
So bad.
All right. We are doing order of operations in reverse. So we're getting rid of any adding or subtraction first, then getting rid of any multiplication division, just like these steps say right here. All right, another way that you can think about it is that you are getting rid of what's farthest away from the variable first. So like this 6 is squished up next to the variable, so I'm not going to get rid of that first. But the 8 is separated by a plus sign. All right, so what are we getting rid of first, the 6 or the 8 in number 9? The 8. And how do I get rid of it? By subtracting 8. So do that on over here to cancel it out. Do it on the right side to keep things equal. Whatever you do to one side, you have to do to the other. So on the left side, what do I have? That's the 6x on the left side because the 8's canceled. On the right side, what's 50 minus 8? 42. Now, are we finished?
No.
Because the x is still with something else, right? So what's the opposite of multiplying by 6? So we're going to divide by 6. Do that on each side. Good. The 6's cancel out to 1, but then 1 times x is just x. 42 divided by 6 is, all right, and now we're finished because the x is by itself. Does that make sense? All right. We're gonna do another one together. We're gonna do 12 together, and then I'll have you try one. And I picked 12 because it's formatted a little bit differently, but it's still the same concept. All right, you get rid of what's farther from the variable. So what are we getting rid of first in number 12? The 7, good. So how do I get that 7 to cancel out? I heard two things, think about it. If I were to add 7, what would that give me? 14, which means it doesn't cancel out if I do that, so I have to
subtract and also
there's a line to be after her. All right, but yes, you subtract 7 because that's how you get it to cancel. Does that make sense? All right, so if it's positive, in order to get it to cancel out, you have to subtract it. Do that to both sides. What happens to the 7s on the left side? They cancel out. Then I have negative 3y. What's 34 minus 7? 27. Good. Now get rid of that negative 3. How do I get rid of it? So I heard two things. Do I divide by 3 or negative 3? Negative 3, because you want the y completely by itself. If there's still a negative there, then it's not completely by itself. You have to keep going in that case. All right, so the y equals what? Positive or negative? Negative 9. Good. Any questions? Does that make sense? All right, the one I'll have you try will be 11. So just 11 for right now. Practice the 2 sevens. All right, so number 11 was the one I had you guys work on. You should have gotten rid of the plus 9 first. All right, so here we showed that opposite of adding 9 is subtracting 9. Do that on each side and simplify. 13 minus 9 is 4. And then over here, you know, the 9s go away. Everyone good there? All right. Now, opposite of multiplying by negative 4 is, let's do the question. Opposite of multiplying by negative 4 is dividing by negative 4. Do that on each side. The negative 4 is canceled to 1. And then 4 divided by negative 4 is negative 1. All right, questions? All righty then. Let's do an example on the back, division type example. So look at 13. What do we get rid of first in 13, the 2 or the 7? The 7 because it's farther away. So what's opposite of minus 7?
Plus add.
plus 7. Do that on each side. On the left side, what's the only thing I have on the left?
X2.
X over 2, good. The 7's canceled when we added 7. On the right side, 9 plus 7 is what's that? 16. Now look at what's being done to the variable. What's opposite of dividing by 2? Multiplying by 2. And then do that to both sides. On the left side, what happens to the 2's? Cancel out. So we have x equals 16 times 2, which is 32. All right, good. Questions there? All right, I'm gonna give you guys one with a fraction. We did learn how to do fractions, so, you know, kind of putting it on you. Try number 16 next. So 2 steps, figure out which one you get rid of first. What do I get rid of first on 16? Do I get rid of the negative 1/3 or the plus 1? The plus 1, how do I get rid of it? The opposite, which is subtract 1. All right, so we'll do that on each side. On the left side, what do I end up with? Negative 1/3 times m, good, because the ones did cancel. On the right side of the equal sign, what's negative 7 minus 1? Negative 8, good. Some people did get that wrong earlier. It is negative 8. All right, you got it wrong, it's okay, just fix it. Now we're at this step. How can I get rid of that fraction? Yes?
Negative 3 over.
Good. All right, you multiply it by the reciprocal. That's how I can get rid of the fraction. Whatever you do to one side though, you do to the other side. So on the left side, what happens with the fraction? Good, it cancels out. We have m equal to, what's negative 8 times negative 3? 24. And then divided by 1 is still 24. All right, good on that. Did we get it the first time? Did we make a mistake, but we know where the mistake was made and we won't make that mistake again? All right, well, let's hope so. All right, that's all I wanted to show you on this worksheet. Any questions before we move on to literal equations? All right, so put that in your binder. Remember, it has 3 holes for a reason. Now have this paper in front of you. This is a paper that was on the back table. So literal equations, you're probably like, what is that? I've never heard about that before. All right, those are equations with more than one. No, that's good. Good guess. Equations with more than one variable. All right, so fill that in for the definition. Literal equations are equations with more than one variable. What is a variable? Yes?
Isn't it like the X and the stuff, like the placeholder thing?
Good, the X's most of the time, really any letter. So if I'm talking about literal equations, we're talking about equations with more than one letter or more than one unknown. All right, so here's a good way to illustrate it, which is to compare it to like a normal equation. So here's our normal one, here's our literal equation. What you need to understand is even though there's more than one variable, you are still doing the same steps. All right, you're doing order of operations in reverse, except for now instead of getting x equals 10 or x equals 1, whatever number, it's going to be x equals a plus b or whatever it might be. All right, so we're kind of just rearranging it. So hopefully these ones, the regular equations, are a piece of cake by now. If we're solving for x, we want the x by itself. So are we getting rid of the 2 or the 5 first? The 5. How do I get rid of it? I add 5. So do that to each side. On the left side, what do I end up with? 2x on the left, because the 5's cancel. On the right, what's 13 plus 5? 18, good. All right, now the x isn't by itself yet. How can I get the x by itself? Divide by 2, because that's opposite of multiplying by 2. Again, what you do to one side, you have to do to the other. The 2's cancel out. So we get x equals 9. Good. All right, so those are our normal equations, solving for x. For our literal equations, still the same steps. You still want to get rid of what is farther away from the x. So am I getting rid of the a or the b?
No, X,
Think about it. Anyone else care to guess?
all of it.
I said a or b. How are you going to tell me c?
What is the number, or what is the letter that's not close to it?
The b. So what would be opposite of subtracting b? Adding b. So do that to cancel it out on the left side. Do it on the right side to maintain equality.
Wait, I have a question.
Yes.
So when you're like hypothetically doing something, my old math teacher said that, if you did do something with it, you need like 1.
I'm not sure.
So like the variable itself would be like 1 if you needed something. I can't remember exactly. But he said it would be like 1.
I don't know.
Like a variable being one?
But I know what
Maybe like the number in front of the variable? is
Yeah,
one,
either
unless
the
otherwise
variable or
stated.
the variable itself.
Okay, we're gonna talk about that more tomorrow.
Okay.
So hang on to that thought till tomorrow.
I'm gonna forget.
All right, back to this. So what happens on the left side of the equal sign? What do I end up with on the left side? AX, because the B's cancel out, right? And now on the right side, since we don't know what C and B equal, is there a way for us to like simplify that?
What?
There's no way for us to simplify this without knowing what either of these equal. So what I'm going to do is just rewrite it. All right, we're just rearranging. Now, look at what's being done to the x. It's still not by itself. What is being done to the x right now? By an a, right? So opposite would be dividing by a. And what you do on one side, you do to the other. Now it's the entire side being divided by a. So make sure it looks like it. Put the line under the whole thing, divided by a. On the left side, what happens to the a's? They cancel out. Then we get x equals, can we simplify anything over here?
No.
So we're just going to rewrite it. So we still did the same steps. We still did the same inverse operations, right? It's just in literal equations, you're rearranging instead of having like a concrete numerical answer. Does that make sense? Any questions before we do some examples? All right. So scrolling down then. So we're not going to do all of these because I think you'll get enough practice on your practice. So let's look at number 4 together. All right, notice these all tell us specifically what to solve for. So if it says solve for t, what do I need to get that t to be? Separate by itself on one side. So look at what's being done to the t in number 4. What's being done to it? So when stuff is squished together with no symbol in between, what does that imply? Multiplication. So opposite of multiplying by p and r would be dividing by p and r. On the left side, we have to do the same thing we did to the right side in order to keep it equal. On the left side, is there anything I can simplify? I don't know. Should we know, right? Because we don't know what any of those equal numerically, so we're just going to rewrite it. On the right side, I can simplify something. What cancels out? The p's and the r's, right? That's the whole reason we did that. Okay, whoever's phone that was, just put on silent. What do I have left on the right side? T. So are we finished? Did we get the t by itself?
Yeah.
So then we can just circle it and call it a day. Does that make sense? The literal equation should just be rearranging to where instead of it being I equals, now it's t equals. All right, but you're still doing inverse operation. Questions? So maybe let's practice with the ones down here. Let's look at 7 together. M equals c minus s, solve for c. What is being done to the c? Come on guys, what's being done to the c? Look at it. We're subtracting the s from the c. What would be opposite of subtracting s? Adding s. That does not mean I'm done. What you do to one side, you have to do to the other. How do I write the left side? Good, equal to, and do we get the c by itself? Yes. Then we're finished. All right, I'm gonna have you guys try 5 and 8 for a second on your own. I know we didn't do a problem like 8, but I'm hoping you guys can still figure it out because we've done inverse operations. So just try those 2 for right now. All right, what is opposite of adding b? Subtracting b. So do that on each side. Sorry, my screen froze. Put your hand down. We're not gonna. All right, do that on each side. On the left side, how do I write that? Y minus b, good. Sorry, my thing is lagging. All right, equals what? And x, how do I get the x by itself? You divide by M. All right, and you're just rewriting it. Questions? All right, you guys have 5 solid minutes. I shouldn't see anyone packed up and ready to go. I'll let you pack up at 12:04. You have 5 solid minutes to work on your assignments. They're all in Schoology. You know how to find those?
Yes.